Hello, Honors Higher Algebra students. This is Mr. Johnson, and this is the first lesson. I know it says lesson 2 here, but we had to make an adjustment due to some of the adjustments to our overall calendar here. So this is actually lesson 1, and this is on properties of exponents. So we are now in what I've called Unit 10 in our Schoology course, which is on exponentials, and this first lesson is on properties of exponents. So we're just going to talk through some of those specific properties here. Okay, let's go ahead and go to our first page. So the first thing we're going to do is just kind of think about investigating these a little bit further, and we're looking at, for example, 2. Let's see, I'll highlight this. So we'll look at 2 to the third times 2 to the fourth, and what do you actually do with that? And that is that you would take 2 times 2 times 2. That's going to be 2 to the third, and then you multiply that by 2 times 2 times 2 times 2, which is 2 to the fourth. And if you notice, you are actually taking 2 multiplied by itself 7 times, and therefore you will be taking 2 to the 7th power. You can see the same kind of thing with 3 to the 4th. That'd be, sorry, let's do this. So 3 times 3 times 3 times 3, that would be 3 to the 4th. And we'll then multiply by 3 to the 1st. And you see that you can just simplify that to 3 to the 5th. You can see the same thing with 5 to the 4th and 5 to the 5th. Of course, that's going to be 5 to the 9th. You just add those up, and then 7 to the 8th. So that's the idea here, is that if you have a situation where you have a number, a base to a power, multiplied by the same base to a different or similar number, you simply just add those up. This is a property of exponents that we will talk about in a second. Let's move on to the next page. This one's a little bit different, and so this is now what's called a power to a power. So it's a little bit more complicated, but it also increases more quickly. Notice that with 3 to the second and then to the third, 3 to the second is 3 times 3. So if I take 3 of those, that would be 3 to the second to the third. That's a power to a power. That's going to be a multiplication 3 to the 6th. I'll just show you this one really quickly. So this is going to be, this is going to be 4 times 4 times 4. That's 4 to the third power. I'm doing that 4 times, so it's a little redundant to write out here, but that's okay. And our last one, so there we go. So we have 4 to the third, and we have it 4 times, and if you just counted them all up, you would have 4 to the 3 times 4, which is the 12th power. So this is how we deal with a power to a power. So I'm not going to write it out, but you have 2 to the 9th, you have 2 to the 8th, you have 8 to the third. So that's how that looks. All right, on to our next page. Okay, so we have now division, so we can kind of investigate this a little bit further. So you can see in the example that we have 3 to the 5th in the numerator, you have 3 to the 3rd in the denominator. You're able to cancel basically 3 of these guys, and you're left with 3 times 3, which is 3 squared. We could see in the next example, we could show that as 6 times 6 times 6 times 6 times 6 times 6 is 6 of those, divided by 6 times 6 times 6. So that would be 6 to the third. And you can just see that you're able to cancel 3 different elements there, top and bottom. So what you're left with is 6 times 6 times 6, which is 6 to the third. And so you can see that mathematically, what we are doing here is we're subtracting the exponents. So, 5 squared divided by 5 to the first, that would be 5 times 5 divided by 5 to the first. We could, of course, cancel one of those. We're left with just 5 to the first. And again, if you were to take and look at the original, and you were to just, take 2 minus 1, you get 1. Or, for instance, on our next problem, 8 to the 10th divided by 8 to the 5th, 10 minus 5 is 5. And so you end up getting 8 to the 5th power. So that's kind of how that works. All right. The next set, we're just looking at kind of a distribution property. So when you're looking, for example, at the original, you have 3 times 4 to the second. Okay, so you have 3 times 4, and you multiply that by 3 times 4. And so you could rearrange that. It's a commutative property of multiplication. So you could do 3 times 3, and then 4 times 4. Well, that's actually 3 squared times 4 squared. We could see that here with our next one. So we have, Keep doing that. So we have 2 times 5, 2 times 5, 2 times 5. We could just organize this as 2 times 2 times 2 times 5 times 5 times 5. And of course, that's going to be 2 cubed times 5 cubed. So there's this distribution property with exponents where we could distribute that exponential power to the items on the inside. So we're distributing those powers. So that next one would be 6 to the fourth times 3 to the fourth, 4 to the second times 5 to the second, those types of things. Okay, so here are really just our basic properties that we have to know. So the product, when you have a base to a power times the same base to a power, you would add those. So you guys can add this in. So a to the m plus n, a quotient. It's going to be a subtraction of powers, a to the m minus n. A power to a power is going to be a to the m times n. A product to a power, so that would be a to the m, b to the m, like that. And you can see some examples below. I guess this last one is not written in, so this is going to be x to the 12th, y to the 15th, like that. Because it's a power to a power, but also the product of the product to a power. Let's go on to the next page. Okay, so if you had a quotient to a power, kind of similar to the product to a power, that you are able to just distribute this through. So you're able to take a to the n and then b to the n. 0, this is for our class going to be 1. We'll see that there's some complications of this as you guys get into higher level math. Negative exponent is really important. So if you have a to the negative n, so take a look at our little example down here. So 8 to the negative second, that's actually 1 over 8 squared, which is 1 over 64. So if you have a to the negative n, that's the same as 1 over a to the positive n. Or if you had 1 over a to the negative n, that's actually just a to the positive n. So it's kind of an interesting property. This one is used all the time, so you have to be very careful that you don't use it in the wrong context. But for example, if I gave you like 1/2 to the negative first power, that would be the same thing as 1 over 2 to the negative first, which is actually 2 to the first, which is 2. So if you take 1/2 to the negative first power, it's actually the same as 2. All right, next page. We're going to try some of these now using our properties. So this is a x to the third times x to the second. This would be a situation where we simply just add the power. So this is going to give us x to the fifth. Here we have a couple coefficients. So notice that we have 2 and we have 5. Those are just our typical numbers. Those don't have an exponent other than 1. And so 2 times 5 is 10. Okay, so this is going to be, oops, I keep doing the same thing. This is going to be 10. And then we have x to the third times x squared. That, of course, is x to the fifth. We did that in the previous one. So that's all we have for 2. And then for 3, that's a power to a power. So that's going to be x to the, 12th. There you go. All right, next page. All right, this is a division. So we have x to the fifth divided by x squared. We subtract those exponents to give us x to the third. Now this one is interesting because it's x to the second divided by x to the seventh. We still subtract x to the negative fifth. However, based on our negative exponent property, this is the same thing as 1 over x to the fifth. So that would be your final answer there. Okay. X to the negative first, by that same negative exponent property, is the same as 1 over x. Okay, let's try with some other variables here. Now, we can't combine these because a and b and c are different, but we know that a to the 0 is 1. So we know that's 1, which means that we're initially left with b to the fifth times c to the negative second. Based on our negative exponent properties, we have b to the fifth, that stays where it is, and c to the second would move to the denominator. So that's going to be our final answer. Ooh, and number 7 looks really complicated. So remember, we're going to deal first with our, let's see, I'll try to highlight this. So 27 over 18, okay, those are numbers, obviously 27 to the first power, I guess, but it's different than what we're dealing with the x, y, and z. So the largest value that would go into both would be 9. So let's go ahead and factor a 9 out of here. We get 3, 9 out of there, and we get 2. So we can simplify that fraction just to be 3 halves. But let's work on the rest of it. So we have 3 halves initially. X to the third divided by x to the eighth is x to the negative fifth. Y to the fifth, remember if there's no number written, this is just y to the first right there, okay? So y to the fifth divided by y to the first would be y to the fourth because we're subtracting. And z to the first, remember that's a 1, divided by z to the fourth would be z to the negative third. Okay, and then we would want to write this in a slightly better way. So we would get 3 halves, and actually, you know what I'll do is I'll do the 3 is in the numerator. The y to the fourth is going to stay there because of the fact that the power is positive. We don't have to do anything with that. And the 2 would be times x to the fifth and z to the third. So that would be our final answer there. Okay, let's try this one. We're going to work kind of from the inside out. So first I'm going to look at the n squared divided by n to the negative seventh. So 2 minus negative 7 is 9. So I get n to the ninth times n to the negative ninth. Okay, well, n to the ninth times n to the negative ninth, I would add those, which would give me 0. So I would get n to the 0. Well, n to the 0 is 1. So 1 to the fifth is 1. So there we go. With this one, we want to make sure we follow the correct order of operations. So we want to take that, remember we distribute this power to everything on the inside. So it would be 2 to the third, then m to the, remember negative 4 and 3 would be multiplied, so it would be negative 12. So I have this, I'll just keep simplifying here. 2 to the third is 8. Actually, you know what? I backed this up. I'm going to do this differently. Okay, so I have, as we look at this, I have 2 divided by 2 to the third. Now this is really just 2 to the first right here. So if I take 2 to the first divided by 2 to the third, I would subtract the powers and I would get 2 to the negative second. And then you got to be careful, it's m to the negative fourth divided by m to the negative 12th. Negative 4 plus 12 is positive 8. And so my final answer is m to the 8th divided by 2 to the second. And I suppose let me simplify it one step further. That would be just m to the 8th divided by 4. Okay, we're going to work on the parentheses first. So remember, we have 2 to the negative third, b to the negative third, a to the, remember we're going to multiply, so we get negative 12. Okay, then we have, let's see, that's going to be, I'm going to move the 2 to the negative third to the left. So then what we get is b times b to the negative third. That's going to add up to give me b to the negative second. A to the fourth times a to the negative 12, add those guys up to get a to the negative 8th. And so we get 1. By the way, if you move everything to the denominator, you get 1. So 1 divided by 2 to the third, b to the second, a to the 8th. And I guess one step further here is 2 to the third is 8. So we would get something like that. All right, this one's really ugly. So on the inside, I think I'm going to work first. I have 4 fifths, and then I have a to the negative third plus negative 4, or negative 3, sorry, negative 3 minus negative 4 is going to be negative 3 plus 4. So a to the first, I'll put a 1 there. B to the 5 minus negative 2, that's going to give us 7. Okay, and now I'm going to distribute that negative 2s to everything. So I have 4 to the negative second, a to the negative second, b to the, remember, get a multiply, negative 14, and then 5 to the negative second like that. This one's kind of a cumbersome one. I hope that makes sense so far. Okay, remember, wherever the negative is, it ends up switching. So I end up getting 5 squared divided by 4 squared, a squared, b to the 14th. And that gives me 25, divided by 16a squared b to the 14th. All right, that does it for properties of exponents. So we will practice more of those in class, but that gets you started for this first lesson. Thank you.